So now let's solve this partial derivative without using Jacobian. Now this is u squared minus v is equal to 3x plus y, and u minus 2v squared is equal to x minus 2y. Now let's differentiate this function partially with respect to x, implicit function. Now this is u squared. Remember, if we have something like this, x squared plus y squared is equal to 1, and we want to differentiate this implicit function, we take it as 2x plus 2y dy dx is equal to 0. Now the same thing, let's differentiate this function partially, because ux means del u del x, uy means del u del y, del v del x, and del v del y. Now let's differentiate this function partially with respect to x using implicit function. And this becomes 2u del u del x with respect to x minus, let's differentiate v partially with respect to x. That's 1. Then the v del x is equal to 3x. Let's differentiate 3x with respect to x. That's 3. Then y is 0. Equation 1. Then also, let's differentiate this one too partially with respect to x. Differentiate u with respect to x. That's 1. Then you put the recognition del u del x minus this with respect to x. That's 4v del v del x. Now differentiate x with respect to 1. That's 1. Y is 0. Equation 2. Now also differentiate this partially with respect to y. That's del u, that's 2u del u del y, 2u del u del y, minus differentiate this with respect to y. 1, that's del v del y is equal to differentiate x partially with respect to y. That's 0. Then differentiate y. That's 1. Equation 3. Now here also partially with respect to y. 1 del u del y minus 4v del v del y. Differentiate x partially with respect to y is 0. Now differentiate 2y partially with respect to y. That's minus 2. Equation 4. Now look at these two equations here. These two equations, we can solve these two, the first two equations, using Cramer's rule. Using Cramer's rule. Now from Cramer's rule, if we want to solve the u dx and the v dx here, that's ux and vx. So this is 2u. The coefficient of del u del x here is what? 2u. The coefficient here is 1. The coefficient here is what? Minus 1. And the coefficient here is what? Minus 4v. Then what will be the determinant? That will be minus 8uv minus 1. That's minus 8uv plus 1, which is the same thing as 1 minus 8uv. And don't forget, we are using what? Cramer's rule. So we can find the u del x in these two equations, and we can also find the v del x. So we want to find the u del x. This is the u del x. This is the u del x. The coefficient here is 2u. Here is 1. Because we want to find the u del x using Cramer's rule, we will not write this. We write 3 and 1, the constant. 3 and 1. But we are not finding the v del x now. So let's write the coefficients. Minus 1 minus 4v. Now what is the determinant? The determinant is minus 12v minus 1, which is 1 minus 12v. So for you to find the u del x, so the u del x becomes this over this. That's 1 minus 12v over 1 minus 8uv. So also, if we want to look for our del v del x, take determinant. Now the coefficient of this, because we are not looking for the u del x, 1, But here we are looking for the v del x. We don't take this, we take 3 and 1. So the answer is 2u minus 3. Now that means the v del x will be this 2u minus 3 all over del x, 1 minus 8u. That's the u del x and the v del x. Now also, equation 3 and equation 4. That means our change in y will be the determinant of this 2u. Coefficient here is minus 1. Coefficient here is 1. The coefficient here is minus 4v. So the answer becomes minus 8uv minus 1. Determinant which is 1 minus 8uv. So you notice that we have the same thing here, 1 minus 8uv and 1 minus 8uv. The same thing here and the same thing here. So for you to find the u del y, determinant, you want to find the u del y now. We're not going to write the coefficient here, but we write the constant 1 and minus 2. So we are not looking for this, we write the coefficients as minus 1 minus 4v, which is equal to minus 8v minus 2. That's minus 2 times minus 1 is 2. So that's minus 8v minus 2. That means the u, the y, rather, the y, the u will be this all over this. So that's minus 8v minus 2 over 1 minus 8uv. Now also, my change in v will be the determinant of, I want to find the v, the y now. I'm not looking for the u, the y, so I'll write the coefficients 2u and 1. So now I'm looking for the v, the y, so I'll not write the coefficients here, I'll write the constant. That's 1 and minus 2. So the answer is minus 4u minus 1. So that means the v, the u is, that's the u, the y, not the y, the u. So that's the u, the y. So here the v, the y, the v, the y becomes minus 4u minus 1 over 1 minus 8uv. We are given these two equations. Differentiate this one partially with respect to x. That's 2u using implicit differentiation. 2u the u del x minus the v del x is equal to 3. And this is 0. u 1 the u del x minus 4v the v del x is equal to 1, 0. Now also with respect to y, 2u the u del y minus the v del y is equal to 1. The u del y minus 4v the v del y is equal to minus 2. Now using Cramer's rule, find this, that's 2u minus 1, the coefficient 1 minus 4v, you get this. So changing u, if you want to look for this, we're not going to write the coefficient here, but we write the constant 3, 1 minus 1 minus 4v, you get this. So that's the u del x. So also for v, we're looking for v now. We're going to write this 2u and 1. We're going to write 2u and 1. And the constant here, this is the v, okay, we write 2u and 1 and 3 and 1. 2u and 1. Then the constant 3 and 1, we get 2u minus 3. So that means the v del x is 2u minus 3 over 1 minus 8uv. So also equation 3 and equation 4, the change in y becomes 2u and 1 minus 1 and minus 4v. You get 1 minus 8uv. So the change in u, you want to find the u del y here. You're not going to write the coefficients here. You write 1 and minus 2, the constant. Then you write minus 1 and minus 4v. You get minus 8v minus 2. So that's minus 8v minus 2 becomes, so our du dy becomes minus 8v minus 2 over this. So also change in v. For us look for the v dy, we're not going to write this. We write 2u and 1. Then we write the constant. So which is minus 4u minus 1, which is minus 4u minus 1 over 1 minus 8uv. So this is the v del x, the u del x, the v del y, and the u del y without using Jacobian.